Hello, Algebra 1. Today we are going to be doing Unit 6, Day 2, Graphing Systems of Inequalities. So the first thing we're going to do is just a recap of graphing one inequality. Make sure you solve for y first. So for number 1, we'll have to add our 2x over. Make sure you don't combine these. And then we'll go ahead and we'll divide by our 3. Notice our 3 is a positive, so we are not flipping our symbol. 15 divided by 3 is 5. All right, so now we're going to go ahead and graph this like a normal line, y-intercept down at negative 5. And then we're going to go up to right 3. And you want to get all those dots on there. Now, because we don't have that equal to underneath our greater than, that means this line is going to be dotted. All right, so take a moment and dot your line. And then one more thing, we need to make sure that we shade. All right, so shading is a really important part about graphing inequalities. So since this is a greater than symbol, we are shading above our line. All right, so that was a recap of what you should already know. Now let's talk about solving a system. Basically, we're going to graph both the inequalities on a grid, and where the shaded regions overlap is called the solution to the system. Okay, so let's go ahead and graph both of these. It's really important that you shade as soon as you graph a line. You don't want to graph both lines first. All right, so let's go ahead. We're going to start 3x minus 9. We're down here. Up 3, right 1. Up 3, right 1. Okay, now I'm actually going to show you two ways to do this. So here's the first one. We're going to have a dotted line. This is a greater than, so again, greater than, we are shading up, which would be this side here. Okay, then we're going to graph the next line. Y-intercept at 1, slope of 3/4, up 3, right 4. Now, you are used to looking for where the lines intersect. We don't care about that here. Okay, they're not going to necessarily intersect at a nice place. Okay, we're actually going to care about where the shadings overlap. So here's my line. I have that equal to, make sure that it's solid. And now really focus on that line only. We have a less than symbol, so we are shading down all the way below that line. Don't worry about the other line. Just shade below our solid line. And what you should see here is we have this green portion. This is what's going to be called the feasible. This is our solution set. All right, so now what we're going to do is check to see if these points are solutions. In order to be a solution, you have to be in the green section, okay, the double shaded part. So 0, -3, that would be a yes. All right, it's in the double shaded region. 2, -3. That's right there. That would be a no because that line is dotted. And then finally 6, 2, that would be here. That's also going to be a no because it's just in one of the shaded regions. It needs to be in both. Okay. All right. So before we go on to the next one, I just wanted to show you another way to do this. I'm going to go ahead and I'm going to get rid of my second line, and I'm just going to stick with the first line here. So instead of doing the shading method, some people don't like how messy that is. So I'm going to show you an arrow method instead. So here's my 3x plus 9. It's a greater than, so I would shade up. So instead of actually shading up, I'm just going to draw these arrows up. Okay. Then I'm going to graph my 3/4 x plus 1. Let me draw that again. See, this is not perfect, but close enough. Okay, and this is a solid line. Okay, and this is a less than symbol, so instead of shading down, I'm going to go ahead, I'm going to draw my arrows down. Now, what you're looking for is the region where the arrows come together. So see how these two arrows are pointing at each other? That tells you that this in between is the feasible region. Now, I do not recommend this method for people who visually can't see it. The double shade is definitely the way to go if you're not sure where it is. But if you can visualize this, this is a little messier of a method. Okay. All right, let's try another one. Number 3. So first things first, we're going to have to go ahead and solve for y. So in number 3, the first equation, let's subtract our x over. And that's all we have to do for that one. Let's go ahead and graph that now. Y-intercept at 5. Our slope is going to be a -1, so down 1, right 1. And that's a lot of dots, so I'm going to just do that really quickly. We don't have the equal to, so this is a dotted line. And it's a greater than, so I am shading above. Okay, or again, you could go ahead, you could draw these arrows up if you want. Okay, now let's go ahead, let's solve the second one. So we're solving for y. Let's subtract our 2x over. Make sure not to combine those. Divide by -3. Be careful, it's a negative. We are flipping our symbol. That's going to be a 2 over 3x, and a 24 divided by -3 is -8. All right, let's graph this again. Down at -8, up to right 3. Again, don't worry about where the lines actually hit. We're caring about where the shades overlap. This is an equal to, so this is a normal solid line. And this is a greater than, so greater than means I am shading above. And you can see where the shades overlap. Okay, so this region right in here, the dark blue, is going to be my feasible region. If you wanted to use your arrow method, you can see your arrows are kind of like coming together right up here. Okay, -2, 9. Yeah, that's in the blue, so that's a yes. 0, 8. Yep, also in the blue. 1, -1. No, it's got to be in the double shaded in order to be a solution. Okay. All right, so there you go. Let's try another one. Okay, both of these we also need to solve for y. So our first equation, though, we just need to divide by 4. That's going to be a -1/4 x. -8 divided by 4 is -2. Notice I didn't flip my symbol because I divided by a positive. But the next one I am dividing by a negative, so I'm going to flip my symbol. That's a -1/3 x. -9 divided by -3 is a +3. Okay, let's graph. I'm going to start down at -2, down 1, right 4. Up 1, left 4. Dotted line, please. And it's a less than, shading below. Okay, and then I have a -1/3 x plus 3, starting at 3, down 1, right 3. Also a dotted line. Okay, and this one is, oh, you know what I just realized? I did it again. I divided by a negative. I said I needed to flip my symbol, but look, I did not. So this is actually a less than 2. I'm glad I caught that now because now I've got a shade less than. I should be shading below. All right, so you can see our shaded region, our feasible region is underneath the bottom line. So 0, -3, yes, that is in that shaded region. -3, -6, yep, that's going to be down there as well. 4, -2, no. All right, it's got to be all the way below the second line. All right, nice job. Let's try another one. Oh boy. Okay, number 5. We've got a lot of different inequalities here. So if you look at the first one, we do need to solve for y. Let's divide by 5. It's just going to be a 2/5 x. The others are solved for. Now this is like a +0. We're starting at the y, or the origin, up to right 5. And this will be a dotted line. And it is a greater than, so where are we shading, everybody? Above. All right, now let's graph the second one. Y-intercept at 6, down 4, right 1. Reverse it. This one's going to be solid. Okay, this is a less than. Less than means we're shading down. So here's my y-intercept shading down. Down is like to the left of this line. Make sure you get everything, okay? Okay, so right now I'm like in this green part. I've got one more. X is greater than or equal to -7. Again, that's a vertical line, so find your -7. It's going to be solid. Greater than, okay, greater than means we're shading to the right for a vertical line because the numbers to the right are greater than -7. So I'm going to go ahead and I'm just shading to the right. Okay, and at this point your paper is probably saturated with ink if you're using highlighters. I'm covering up my numbers here, but we can see that that really dark black region, that's going to be my feasible region. Okay, so let's check these points. 2, 5, that's going to be a no. It's got to be in that black region. -5, 5, all right, I can't really see my numbers, but that's going to be up here somewhere, so that's going to be a yes. -4, -4, that's going to be over here somewhere, but then down, so that's going to be a no. All right, again, you've got to be in the region that has all of the shading. Okay, all right, we're going to do one more. We have y is greater than or equal to -5. Using Hyvix, we know that's a horizontal line. It's going to be solid. Make sure you're crossing through the y-axis. And it is a greater than, so we are shading up. Okay. And then this next one, I do need to solve for y. So let's subtract that 4x over. And let's divide by -6. Watch your signs and your symbol. We're dividing by a negative, so we're going to flip the symbol. I'm going to make sure I actually do it this time. -4 divided by -6 is 2/3. -12 divided by -6 is a +2. All right, let's graph. Up to right 3. Down to left 3. And we're going to have a dotted line because it doesn't have the equal to. This is a less than, so again, we're going to shade below, and you should see you kind of form this little triangle in the middle that is being shaded dark blue for me. All right, 6, 6, let's see, 6, 6. That's actually a dot, but this dot is a dot on a dotted line, so this is a no. If it was a solid line, it would be good. -7. -6, that's down too low. It's not in the blue part, so this is a no as well. And then -1, -9, also too far down, so this is also a no. All right, so that's your lesson on systems of inequalities. I hope this was helpful. Please let me know if you have any questions. Bye.